Alright, so here's the Chapter 10 review. If I was going to do this, there is a problem just like this that the book does in the video of 10.1. It talks about how this really means that you can have 4.6 times 2, and then you can break that up as to 2 to the n times 2 to the negative 1. And then what happens right here is 2 to the negative 1 really means 4.6 times 2 to the n. That just really means times a half. Well, this is a number, and this is a number, so I can get, if I can multiply those together, get them close. So what they do is they do 4.6 times a half times 2.n. What they did is we just did the commutative property and put those close together, and then when you finally put those together, you get 2.3 times 2 to the n. And that is all they are looking for. That is the answer to the question. You have taken it from the geometric sequence and put it in an exponential function. This is an exponential function. All right, next ones, it just asks you if they're growth or decays. This one, A, is really easy. That's bigger than 1, so it is a growth. This is between 0 and 1, so this is a decay. This one is the little tricky one. When you have this, this really means 1 over 8, and you have a negative x and a negative x. I just distributed, and yes, you can do that because there's no addition in there. You can just distribute it right to those guys. If this was 1 plus 8, that's not good. Anyways, to the x, you couldn't just distribute it. You've got to, actually I would add make it that 9, but anyways, you got to know the difference between the two. You can do this because it's just, that's what happens when you have something to a power. You can distribute that, and then what you end up with is when you have a negative, it sends it down. When you have a negative, it sends it up, so it becomes 8 to the x over 1 to the x, and then I can kind of pull that x back out, and I get 8 to the x, or 8 over 1 to the x. Either way, it could be written like this. And all I care about is this is bigger than 1, so it is a growth. All right. For this one, I would go ahead and make an x and y chart real quick. X and y chart. If I plug in 0, I get 1 out. So, even make a graph for it. If I plug in 2, or 1, I get 5 out. So 1, 2, 3, 4, 5. If I plug in 2, I get 25 out. So it's just going to go, it's going to shoot up really high. All right, if I plug in a negative 1, I get a 1/5, because remember that makes it 5 to the negative 1 makes that, sends it down to the denominator, so I get 1/5. So it's 1/5, and so it's looking like this, and it's going to keep on going like that. Remember, we said all of these, you'll never ever be able to take anything 5 to any power will never ever equal 0. You'll always have something. It might be 1 over a billion, but you still have something. Kind of like Tommy Boy. So you're saying there's a chance. There's that 1 out of whatever. There's something there. It's not 0. And so that would be my asymptote. So the first question it asks is for an asymptote. And my asymptote would go ahead and say y equals 0, because it will never happen. The intercept, it says intercepts. Well, it's never going to touch the x-axis because that's where y equals 0. So there's only going to be 1. And that's the y-intercept, and my y-intercept is when I plug in 0 for x, I get 1 out. My end behavior, how is this end looking? Well, as x is going to, well, where's x going? To negative infinity. Y is getting really, and keeps getting really close, but never touches 0. As x goes, now it's going to the right, so x is going to the right, it's going to positive infinity. My y is going to, it's going up forever, positive infinity also. That's all it's asking for that. For number 4, sorry about that. Number 4, all it's asking is to write a function. It is not asking you to solve anything, it just wants the function, but you notice that this is going to be in 1995. And actually looking at this, they probably should have made this in 1996. That's a typo. So this should have been 96, because that would throw some stuff off. So this is going to be since 1996. So if I write the function, I know that my beginning was, how many people were there? There was 15,500. And this is population, so I know it's going to be NERT, or PERT, whichever one you're used to. I know it's going to be this formula because population is consistently growing. It's not stopping. It's growing, 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 growing. Right now it's growing, it's growing, it's growing, it's growing. It doesn't have a compound quarterly or annually or anything like that. It's always growing. So it's going to be the E one. And so it's going to be 15,000 times E to the rate, which is as a percent. So I need to change it to 0.014 as a decimal, and then times my time. That's my equation, because they need to give me my time in order to solve how many people there are going to be. So the next question says, well, how many people are there going to be in 2026? If you don't believe that that our city managers and people like that are using that, you're crazy, because they have to think about roads, they have to think about schools, and they have to figure out what the population is going to be to make sure they have enough room for all these people. So they use this kind of thing, and so they're predicting how many people are going to be there in 2026 to make sure that there's enough stuff. And so we go, okay, my population would equal 15,500 E to the 0.014, and how many years is it from 96 to 2026 would be 30, so my T is 30. So this one is a very straightforward question. What you're going to do is you're going to, in a calculator, multiply these numbers together. So you're going to hit in your calculator 0.014 times by 30. You're then going to hit in your calculator e to that power. If you're using my calculators in class, you'd have to have this number first, and then you hit shift and E, and it will give you a number, and then you go ahead and multiply that 15,500, and you should get an answer of about 23,590, and you would go ahead and round to the nearest whole number, because people are wholes. Yeah, a couple people might have a couple different things inside them, but anyways, there's always just one whole person. We don't have half people. So here we go. If I was going to do a transformation, and I want to know, what does this negative do? Remember, the negatives here, they translate that, and it's a reflection. So this is a reflection over, and since it's outside, it's going to be over the x-axis, or where y equals 0. Either way, you can say it reflects over y equals 0 or x-axis. I don't care which one you put. If I had j of x equals, and this was log of negative x, then it would have been a reflection over where x equals 0, and that would be the y-axis. So you need to know the difference between these two, what this negative does versus what this negative does. All right? Then we go to the next one. And it says right here, what is this going to do? What is this going to do? And what is this going to do? You have to remember, guys, you are pretending like you have the normal log function. Okay? So if you have the normal log function, it's going to look something like this. You have the normal log function. If you do this, this, and this, it's going to move all these x and y's. This is going to move every x over to the left 2. So all these x's, all of this is going to be left 2. It's going to go up 4, and it's going to be stretched by 6. So you're going to multiply it by 6, then add 4 more. And so it's going to be somewhere, this point might be moved all the way up there. That's what you are trying to tell these people, how it's transformed. And so my 6 right here is a stretch by vertical stretch. By 6, you need to say something about stretch and vertical in there, because there is a horizontal one, so you definitely need to put vertical in there. You need to say something about, since this 2 is inside, it moves it actually left 2, and then you need to say something about up 4. You can say a horizontal shift. Horizontal means left and right, or you could say vertical shift, which would mean up and down. And you would have to say, if you say horizontal shift, you would say -2, or you would say vertical shift up 4, something like that. They just need to see these kind of phrasings. Remember, if this was even a -6, if this was a negative 6 out here, that still makes it a stretch. The negative does not affect that it's not a stretch. It's still a stretch. The negative would just also reflect it over the y-axis or the x-axis, just like this one did. So hopefully you're starting to get where all these translations are moving this stuff. Same kind of question as the next one, just with e. Doesn't matter if it's e. There's no parentheses there. You have to understand that's inside parentheses. So inside parentheses does the opposite of what I think, so it's going to move it to the right 4 and up 10. If you put something like that, you'll be good. All right, what is the inverse of this? Remember, inverse means switch the x and y. So what I always do is I start off with just putting the x and the y in the original equation. So I got, this is the original. Now switch. And so when I do that, I know that I want to make this say y equals. My whole function's got to say y equals. Well, there's no way that I'm going to get to do y equals by itself with this log form. So I go, you know what? How can I get rid of log form? Is if I turn it into exponential form. We practice turning log form into exponential. Remember, it's 10 to the power of x equals y. So it'd be 10 to the power of x equals y. And then lo and behold, y is all by itself. Y would really be represented, because it's the inverse, I want to tell the person it's the inverse, so I go f at -1, or f -1x, which just says it's the inverse of the function, equals 10 to the x. This really just represents my y, which is right there. Okay, that would be my final answer. Translate log x to the left 5 units. So this is left, it's inside parentheses, so it would be f of x would equal log, and then parentheses, x left, I want to put -5, but I know it's the opposite, so I put +5. Alright, this is very similar to the first problem that we did. Alright, change it to exponential function. So you take 10.3 times 6 to the n times 6 to the -1. 10.3, change this to a 1/6, so times 6n times 1/6. Remember, if you have a negative exponent, just sends it down to the denominator. Move this guy so it's by this guy. 10.3 times 1/6 times 6 to the n, and when you do that, you get an answer of 1.72 times 6 to the n. All right. Is this a growth or decay? Well, again, what I can do is I can say, you know what, that means 5 to the -x over 8 to the -x. What does the negative exponent do to it? It just says, hey, you go down, and since this has a negative exponent also, it says you go up. So it becomes 8 to the x over 5 to the x, which is really just equivalent to 8 over 5 to the x. I can rewrite it like that. And that shows me that this number is bigger than 1. So this is a growth. All right, number 11. Number 11, I'm going to use, this is not growing. This is compounds monthly. It is not growing all the time. So I'm not going to use my NERT formula. I'm going to use my A at t equals the principal times 1 plus the rate divided by the number times compounds raised to the time it compounds times the time. And so they give me all that information. My principal is going to be, this is P. My interest rate is going to be, that's R. My compound monthly means that it's 12 times a year. That's my N. And 8 years is my T. So I just plug all that in. Equals 35,000. Is it just 35,000? Sorry. 35,000. 1 plus, change this to a decimal, 0.04, divided by, how many times is monthly? 12. To the 12 times 8. And so if I was doing this, I know in my calculator, I have to do all this first. But I'm going to raise it to this. And I know I'm going to do that, like when I raise it, I need to know that number. So I'm going to do that. That's 96. So in my calculator, what I'm actually going to hit is I'm going to hit 0.04, then divide by 12. That gives me this number. I'm then going to keep that number in my calculator and just hit +1. Then I'm going to keep this number in my calculator and I'm going to hit the XY button and I'm going to hit 96. Remember, I do not want to round. I don't want to, clear anything out. I want to keep it all in there. So then I get this whole number when I raise it to 96 and I times that by 35,000. When you do, you should get $48,173.83. That's how you should do that problem. Yes, you need to get that number, and the way you're going to get that number is without rounding. So again, 0.04, divide by 12, add 1, raise to the 96. That's why I did that first, because I wanted to know what I'm going to be raising it to. And then I multiplied by 35,000. Order of operations, guys, rules. And it is so important for us to follow those. So here we go. Change to logarithmic. Remember, this is my base. So log 5 is then right next to it is my answer. So 120, 1 over 125. And that should equal the power, which is -3. And I checked that because I'm much better at going from log to exponential. So I check. And I go, it should say 5 to the third power equals this. 5 to the -3rd power equals that. Check. 13. 2 to this power should equal that. So 2 to the -5th equals 132. And you can check that in a calculator. You can raise to the -5 and get an approximation as a decimal. You can then take 1, divide it by 32, and it should be that same decimal. All right, last 2 questions. All right, so if I was going to do this, remember, whenever it says, write the inverse. Inverse means you switch the x and y. So I always start off with writing my equation with an x and a y in it. So I've replaced this f of x thing. I don't like that. I just want a y in there. So I write it like this. I switch my x and y, so it becomes x equals 6 to the 2y. I'm not going to be able to get this out of the exponent without changing it to log form. So I'm going to have to change this to log form. So I know that it's log, my power, or my base, which is 6, so what it equals, x, equals 2y. And then boom, I've got the 2y out of the exponent. And now I can solve. Remember, all these functions, you need them to say y equals. So once I switch the x and y, I then got to move it around until it says y is all by itself. So the why I took it to log form is to get that y of the exponent, so I could then get that 2 away from it by dividing by 2, and I get log 6x, so that's base 6, x divided by 2 equals my y. And so that would mean, remember, my y is just my f of x, but since it's the inverse, they wrote it as f -1, so it's log little 6x over 2. All right, last one. Again, first thing first, write it with a y in there. It's just much easier. Log x to the 7th. So I switch it. It becomes x equals log y over 7. I don't like this again. I need to get that y by itself. I'm not going to get rid of that log unless I can change it to exponent power, exponent form. So I go, okay, this is base 10, since there's nothing there. So I go 10 to the x equals y over 7. Well, I want to get rid of that y by itself. So the y is being divided by 7, so I times by 7. I times by 7. This has been a huge thing, guys. Y equals 7 times 10 to the x. You cannot multiply the 7 times the 10, because the 10 must be raised to the x power first, then multiplied by the 7. This is not equivalent to 70x. That is way wrong. If you don't believe me, put a 2 in for here and solve. And if you do, you get 10 to the second is 100. 100 times 7 is 700. 70 to the second power is, you got 7 times 7, which is 49, and 2 zeros at the end. It's 4,900. This is only 700. They're not even close to being the same. They're not equal. So this is the right form. You do not multiply the 7 times the 10. So 7 times 10 to the x. That is your final answer. Leave it like that. Please do not make that mistake on the test. All right? Study this up. You study this review, you should get everything that you need for this test. Have a great night, and I look forward to seeing you guys tomorrow.